Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023, Paper 4, Variant 2. In today's lesson, we will talk about electromagnetism, magnetic field, electric field, DC circuits, and also we will discuss astronomy and cosmology. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question 8 part A1 says, what is meant by a magnetic field? Magnetic field simply is a region around a magnet where another magnet will experience a force, or we can say is a region around a magnet where a magnetic pole will experience magnetic force. That we also need to understand there is no magnetic monopole in nature. Means magnetic monopoles do not exist in nature. We don't have single north pole, we don't have single magnetic south pole. So always when we have a magnet has two poles, one is north pole and one is south pole. So for this question, simply magnetic field means that the region around the magnet. So this region is the magnetic field. So simply we can say for the answer of this question, region in which a magnetic pole experience a force, or we can say an other magnet will experience a force. For the second part, we need to define direction of a magnetic field. Define direction of a magnetic field. So you can see in this case we have these lines. These lines are representing magnetic field lines. The question is that how we draw these arrows, for example this arrow to the left, and how we have drawn this arrow also to the left. So imagine that if we place a north pole here, so simply imagine if we have north pole, single north pole. What is direction of force on this one? Direction of magnetic force on this one. This will be to the south pole, mean in direction of this arrow. Now we can also imagine if we place north pole here, so this is the north pole. Let me draw a little bit bigger one. So imagine that we place over north pole here now. So this is north pole only. So the force on this one will be to the left. So that's the reason this arrow is to the left. And if we place north pole here, for example, at this point, if we place the north pole, the force on this one will be to the right, and so on. So this is how we draw magnetic field lines, and direction of magnetic field lines tells us direction of force on north pole. So these points you need to understand. I hope this makes sense to you. So for the answer of this question, simply you can say in direction of the force on the north pole. So if we place north pole here, for example, at this point, direction of force on the north pole will be this way. Means north pole will experience force to the right. So this is how we need to answer these questions. And electric field. So if we try to understand a little bit about electric field, imagine that we have this is a positive point charge. So how we draw the electric field? So important point to compare these two things together. So these are the electric field lines. So the arrow on this one has to be to the right, arrow we have to draw here to the left, and arrow here we have to draw in upward direction, here we have to draw in downward direction. Now the question is that why we have drawn these arrows in this direction? Because in this case we are assuming if there is a positive point charge here, direction of force on this one will be to the right, and if we place positive point charge here, direction of force on this one will be to the left, and on this one will be in upward direction, on this one will be in downward direction. So this is how we decide direction of electric field, and this is how we decide direction of magnetic field. Part B says figure 8.1 shows a negatively charged metal sphere. On figure 8.1, draw 4 lines to show the electric field and its direction. So first of all, we need to understand we have metal sphere. So the electric field inside any metal sphere should be equal to 0. So simply we can write on here electric field inside has to be equal to 0. So the electric field lines now we need to draw from the surface. So very important point. Now you can imagine simply we have negatively charged particle. So this particle has negative charge. So how we can draw the electric field lines? So direction is important. So we can imagine unit positive charge as we discussed before. Imagine that we place one unit positive charge here. So the force between these two will be attractive, and this positive charge will experience force to the left. We can also imagine if we place unit positive charge here, this will be attracted by this negative charged. So it will be force on this one will be to the right. If we place unit positive charge here, this will be attractive. So the force on unit positive charge, this will be in downward direction. And if we place unit positive charge here, force on this unit positive charge will be in upward direction. Mean force is towards the charge particle, negatively charged particle. So if we have understanding of these things, we can draw the four lines here. So we can draw one line here, we can draw one line here. They have to be equally distributed, and we can draw one line here, we can draw one line here, and direction has to be towards the sphere, mean to the sphere. So you can draw these lines, they have to touch this sphere. So this is how you can draw electric field lines for negatively charged metal sphere. Part C says figure 8.2 shows a circuit. The three cells are identical and have zero resistance. The resistors R1, R2 and R3 also identical. The reading on the voltmeter is 6.0 volts. When the diode is conducting, it has zero resistance and zero PD across it. Determine the EMF of one cell. So we have EMF of these three cells, that is equal to 6.0 volts. So we have one cell here, we have two cells, this is the second one and this one is third one. So simply we can say in this case total EMF, this is equal to 6.0 volts. So we can say n times EMF of single cell, this is equal to 6.0 volts. So from here we can find out EMF of single cell. This one has to be equal to 6.0 volts divided by 3. So we will get this is 2.0 volts. So the final answer we can write on 2.0 volts. Second part says determine the ratio of PD across R2 to the PD across R3. So it simply means that we need to find the ratio between V2 and V3. V2 is the PD across R2. So we can say this one is V2, the PD across this second resistor. And here we can write down V3. So this is the PD across R3. So first of all, we need to understand for this circuit how current will flow. Current, let's say this current is I0, and current here, let's say this current is I1, and we can say this current, let's say this is I2, and current here we can say this is I3. So first thing you need to understand, I0 and I3, they have to be the same. I0 and I3, they have to be the same because current entering a battery and leaving a battery has to be the same. So this current I3 is equal to I0. Now we need to find out what is I1 and I2. I1 and I2, they have to be the same because these resistors, they have the same resistance, and the PD across this resistor and this resistor. So let me write down here, let's say this PD is V1, and PD across R1 and R2 also has to be the same. So we can say V1 has to be equal to V2. So current we can write down I0, this one has to be equal to I1 plus it has to be equal to I2. Means current at this junction, it will split into two parts, and it will split equally into two parts because PD is the same, current is the same. So we can say I1 has to be equal to I0 by 2, and I2 also has to be equal to I0 by 2. So the sum of these two is equal to I0. Now we can simply write down here V2, this has to be equal to I2 times R divided by resistance is the same. If you want to write down R2, you can also write down, and this will be divided by I3 times R3. I2 is equal to I0 by 2 times R, and this is divided by I0 times R. So simply in this case, we can cancel I0 with I0, we can cancel this R with this R. So we left with 1 by 2. So it means the ratio between V2 and V3, this ratio is simply equal to 1:2. So this is our final answer. This is what you need to write down. Third part says all the cells are reversed. For part 1, we need to state and explain the change in current in R1. All the cells are reversed. It simply means that negative terminal becomes positive and positive terminal becomes negative. So we can draw these blue lines to represent positive terminal. So in this case, current will flow like this now. At this junction, no current will flow this way. So we can say I in this branch has to be equal to 0 because this diode is connected in reverse bias now. So we can say this is connected in reverse biased. So current will flow like this. So this is important one. You need to understand how current will flow in this circuit. So current will flow like this. So simply we can say current I R1, this will be equal to 0. Why? Because diode is connected in reverse bias. So we can say diode is now connected in reverse biased. So this is the point you need to understand. Now let me show you the answer, how you can write down your answer. So this is how you can write down your answer. If you write down these 2 points like this, you will also get 2 marks. For the second part, we need to determine the new value of the ratio of the PD across R2 to PD across R3. So in this case, you can see, let's say this current is I naught. So the same current flow through this resistor and also through this resistor. They also have the same resistance. So it simply means that ratio between V R2 and ratio between VR3, this ratio has to be the same, means 1:1. So that's all what you need to write on. I hope this one is clear to you. That's all for today's lesson. I hope you have better understanding of electricity now, and remaining 2 questions I'll be uploading as soon as possible. See you in next video. And if you have any questions, please leave your questions in comments and I will also try to answer your questions as soon as possible. Bye for now.